Section 7.4, vectors. We're going to represent vectors geometrically and algebraically. We're going to find unit vector in the direction v and write the vector in terms of its magnitude and directions in this section. A vector has magnitude, and the magnitude is how long it is, and it has a direction, so which way it's going. The length of the line shows its magnitude, and the arrowhead will point in the direction that it's going. The zero vector is 0, 0, with those little angled brackets. The opposite of vector v, which is v sub 1, v sub 2, is negative v, which would be negative v sub 1, negative v sub 2. The first component of the vector is v sub 1. The second component is v sub 2. Also a scalar, that is a real number. And a position vector is a vector with the initial point at the origin, at the point 0, 0. Operations on vectors. So if v is equal to v sub 1 and v sub 2, and w is equal to w sub 1, w sub 2, those are vectors, and c is any scalar, then v plus w would be, you add the first terms together, v sub 1 plus w sub 1, and your second term would be v sub 2 plus w sub 2. Subtracting, you'd subtract your first terms, you'd subtract your second terms. And c times v would be c v sub 1, comma, c v sub 2. So there's vector addition, vector subtraction, and scalar multiplication. Magnitude, if I want the magnitude of vector v, I would write these two double lines. This means magnitude of v. Or if I have 2 points going from p to q, that's a vector, the beginning point of a vector, the ending point of the vector. The magnitude would be the double lines between, or on the outside of the p, q. Okay, so both of those would be vector magnitudes of vectors. Vectors also, when you read your book, you'll see that they're written in bold. They'll be bold. And vectors are only equal if they have the same magnitude and same direction. So they're the same length and they go the same direction. A unit vector has magnitude equal to 1. So if I have the vector u, and here's vector u, the vector v, the vector w, I am going to do this a little differently than your book does it. If you want to do it the way your book does it, you can. I personally think that this is easier. So I am starting with, I want to do 2v plus 3w minus u. This is v, so 2 times v would be from here to here. So that's what I have here. There's 1v, there's 2 v's. And then now at the end of that, we would do plus 3w. W goes down this way, down 3 over 2. So we would do that 3 times. So down 3 over 2, sorry, or down 4, sorry. What was it down? No, down 3, sorry. Down 3 over 2, down 3 over 2, down 3 over 2. Okay? So this one is your 3w. See? Okay? And then minus u. Since u goes up, negative u would go down. So instead of going up 4 units, I'm going to go down 4 units. 1, 2, 3, 4. So my final vector is the blue one. I started here, I ended here. So that's why that has my arrow. So there's my vector. And you're done. Makes it easier to have grid paper, the graph paper, if you're going to do this, because it's easier to draw them. This is the way I do it. Your book does it differently by drawing parallelograms. If you like the way your book does it, you can do it that way. I think this way is easier. Remember, a position vector has the initial point at the origin at 0, 0. So the vector v has an initial point of 6, negative 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That red dot is 6, negative 4. Its terminal point, its ending point, is 1, 1. 1, 1. So there's the ending point. Write it as a position vector. So that means I'm going to start here, end here, but this point I'm basically going to move to the origin. Okay? So if you want to do it algebraically, you would take your x sub 2, which is 1, minus your x sub 1, which is 6, so 1 minus 6, and then you would take 1 minus a negative 4, and get negative 5, 5. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this, right here, is really the same vector. That's that same vector, just moved over with this origin being there. So there it is. This negative 5, 5 is my ending point. It starts at 0, 0. So that's that vector. Negative 5, 5. Okay? Next, example 3. Vector v is negative 1, 2. Vector w is 3, negative 2. I want to find 2w minus 3v. Okay? So first of all, to find 2w, I would multiply my w vector by 2. So that's what I did here. So there's 2 times w. To find 3v, I would multiply 3 times my v vector. So here's my v vector times 3, which is right here. So now I have subtraction, so I'm going to subtract them. So I have 9 and negative 10. And now to find the magnitude of that, if you take your first term and square it, plus your second term and square it, and then take the square root. So the magnitude would be 9 squared plus the negative 10 quantity squared, and the square root of that, which is 181. And let me show you where that formula comes from. Look at this vector here. This right here is 5, and this right here is 5. A leg squared plus a leg squared equals a hypotenuse squared. So this is 5 squared plus 5 squared, the square root. That's the length of that, the magnitude. So it's really coming from Pythagorean theorem. Your x distance squared plus your y distance squared is equal to the vector length squared. And your vector length is magnitude. And that's where this is coming from. Unit vector u in the direction of vector v is equal to radical 5, negative 2. So to find the unit vector in that direction of the vector v is equal to radical 5, negative 2, first we need to find the magnitude of vector v. So radical 5 squared plus a negative 2 quantity squared, which would be 5 plus 4, which is 9. The square root of 9 is 3. So now to find the unit vector is equal to always 1 over the magnitude is 3, times your vector, and your vector is radical 5, negative 2. So I would do 1 over the magnitude of v, 1 over 3, and then my vector v. So I'd have radical 5 over 3, negative 2 over 3. So there is a unit vector. So if I go radical 5, 3 to the right, and 2/3 down, the length from 0, 0 to that point would be 1. It's a unit vector, a length of 1. 7. In the Cartesian coordinate plane, 2 unit vectors that lie along a positive coordinate axis, the axes are important. And these vectors are vector I, which is 1, 0. Okay? So that would be that vector. And vector j, which is 0, 1, which would be that vector. Okay? So find the expression for u is equal to 2i minus 5j, and v is equal to negative 3i minus 2j for 2v plus 3u. So 2 times v plus 3 times u. 2 times the u vector, or v vector, is right here. 3 times the u vector is right here. And then combine your like terms. The i's cancel out, so you just have negative 19j. Or, if you wanted to put it in terms of a vector, j is 0, 1, so you have 19 times that, so you have 0, negative 19. And you're done. Next one, find the expression. So I want the magnitude now of 2v plus 3u. Well, we did that before. We found this at least. We didn't find magnitude, but we found that negative 19j. So all of this up to this point is the same as that last slide. Now we just find the magnitude. So my x-coordinate is 0 and my y-coordinate is negative 19. So it's 0 squared plus, in reality it's negative 19 squared, it's still a positive. And then take the square root, so you get 19. And you're done. Next one, the formula v is equal to the magnitude of v times the cosine of theta I plus the sine of theta j expresses a vector v in terms of its magnitude, which is v, magnitude is v, and its direction angle, theta. So I want to write the vector in the form of v sub 1 I plus v sub 2 j. Given that the magnitude is 3 and the angle, theta, is 150 degrees. So just plug it in the formula. 3 and theta is 150. So I plugged it in the formula, and you still need to know your good old unit circle. If that's 150 degrees, that's 30 degrees, so that's 1, 2, radical 3. So the cosine would be negative radical 3 over 2, which is right here. And the sine would be 1 over 2, which is right here. So I just did a substitution. Instead of cosine of 150, and instead of sine of 150, I substituted the values. And then I distributed the 3. So then you have negative 3 radical 3 over 2i plus 3 over 2j. And you're done. And the last example that I want to do for this section, using that same formula again, I want to find the magnitude and the direction angle of the vector. V is equal to 2 cosine 300i minus sine of 300j. So let's plug in what we know. 300. This is 180. This is 270. There's 300. So that's 60. 1, 2, radical 3. So that's what your triangle looks like. Cosine of 300 would be 1/2. That's what I have here. Sine of 300 is negative radical 3 over 2. And that's what I have here. So I have 2 times 1/2 I minus a negative radical 3 over 2j. Minus negative becomes plus, and distribute the 2. So you just have I plus radical 3j, which is this vector right here. Okay? The magnitude of that vector would be the square root of 1 squared plus radical 3 squared, which is the square root of 1 plus 3, which is the square root of 4, which is 2. So there's my magnitude, which is 2. And tangent of theta, you know, is radical 3 over 1. There's the tangent of that. Here's my vector. Okay? So there's my vector right there. 1 radical 3. Let me just show you how I'm getting that. 1 over radical 3 up. 1 over radical 3 up. So this angle right here is 60 degrees. So theta is 60 degrees. And you're done. Opposite, adjacent. Tangent is opposite over adjacent. Okay? And those are the only sides I'm given. That's why I use tangent. Even though it's an triangle, you know, it's a 1, 2 radical 3 triangle. You're given an opposite and adjacent side. if this was not a triangle that you would know, you would take the inverse tangent of each side, and that would give you theta is equal to the inverse tangent of radical 3 over 1. In your calculator, if you put in your calculator, you'll get 60 degrees. Homework is on Schoology.